Hi, welcome to my video on the review of linear inequalities with a single variable. As in most of my units, I end the unit with a review, which can be treated as a quiz. So this review has a total of 38 points. So if you find and do your answers on 4 of 4 blank pages, then you can pause the video, work out the questions on each page, or you can work out each question and record your marks and then get your total at the end and to see how well you will do on each of my units. But let's review linear inequalities with a single variable. Here we go. Practice. So what you can do is pause the video, work all these questions out that you can see here right now. You can do them one at a time, or you can do the whole page. But when you do, if the answer is right, record the marks here. And when you're finished, total at the bottom. You can do that for each page. Here we go. State the inequality as a mathematical sentence. X is less than 4. X less than 4. Place less than, equal to, or greater than in blank if the statement is true. So we have to do BEDMAS. So we work out the inside of the brackets first to get a -1. And a -1 to the 20th power. A -1 to an even power is 1. So that gives us, when we multiply here, we get 4. And 4 compared to 1, 4 is greater than. Give yourself a mark for each of these if you're right. List the members of the set. This is set builder notation, meaning this is a set of all x such that, line, x is less than or equal to 4, where x belongs to the whole numbers. We know, or should know, that the whole numbers are 0, 1, 2, 3, 4, ... So we're talking about all the whole numbers equal to 4 and less than. So that's if I go this way, so there's all the whole numbers that are less than 4. 0, 1, 2, 3, 4, including 4. Give yourself a mark if you're right. Number 4, graph each. This is the set of all x such that x is less than 3, where x belongs to the integers. Notice this is x is a line. Remember we looked at in this unit, if you have x comma y here, you're doing ordered pairs on a plane, but we're talking about a line. So less than 3, integers. So that's integers are dots. So not 3, less than 3. And 2, 1, 0, -1. And they can go on. So there's the answer. 3 dots on the end indicates it's moving to the left. Set of all x such that x is greater than or equal to -2, where x belongs to the reals. So the integers and natural numbers and whole numbers are dots, but the real numbers is shading. So we start at 2, start at -2, and -2 is included, so it's a solid dot. And we shade greater than is pointing, that's pointing to the right, so we shade to the right. So real numbers is a shading to the left or right. There's the answer. And C, set of all x such that x is less than 0, where x belongs to the reals. Again, reals is shaded, so is not equal to 0, so that means it's a hollow dot, because 0 is not included, and less than is on the left. So here's all the numbers, that's to the left of 0, less than. So there. And notice it's a hollow dot. Notice up here we had equal to 2, so it's a solid dot. Give yourself 3 marks, or hopefully you're all right. Number 5, which one is correct for each? So which one is correct? So we have, I said for each, which was only one here, so I could leave the each out. Which one is correct? So is this real numbers? We can't, real numbers means shading, so nope, it's not real numbers, because real numbers would have shading. Natural numbers, set of all x such that x is greater than -1, where x belongs to the naturals. So, and that's wrong, because greater than -1 would include the 0, and 0 is not a natural number, so that's not right. And we have greater than or equal to 0 belonging to the whole numbers, and this one is correct. Greater than or equal to 0, there they are, going to the right, and we start at 0, and 0 is a whole number. And greater than or equal to 0, and this one is also correct. Notice, natural numbers greater than 0 are, can we take? No, we can't take that one. Why? Because when we go greater than 0, this set has 0 in it. The natural numbers don't have a 0. So even though greater than 0 is the natural numbers, but this set is not all the numbers greater than 0. Number 6, graph. The set of all x such that x is less than 1 1/4, where x belongs to the reals. So 1 1/4. So there's 1, there's 2, 1/4. There's a half in the middle. There's 1/4, 2/4, 3/4. So between 1 and 2 is divided into 4 parts. So I have to take 1 1/4. And this number is not equal to, so we had a hollow dot right there. That's 1 1/4. And we have to go less than. So less than is on the left. So there it is. Again, repeat. It's a shaded line, shaded, and it's a hollow dot because it's not an equal sign. Give yourself another mark if you're right. And total up your page out of 8. Let's go to the next page. So again, pause your video and work out all these answers, and then when you get them done, press play and see how many marks you're going to get. Number 7, if C is less than 0, that means C is negative. So if I take a negative number, multiply, and get A times C and B times C, that means because it's multiplying by a negative number, the greater than changes to a less than. So if we got a less than sign, give yourself a mark. Now we're going to solve. In number 8, we're going to solve the 4 of these. In inequality, we divide by -2. They cancel out to give me x, and because I divided by a negative number, it changes to a greater than equal to, and I get a -5. All x's go on the left side the way I do it. We move it over, make it negative. All the numbers go on the right side. When you move it, the positive becomes a negative, the negative becomes a positive. X is on the left, numbers on the right. That gives me 12x is less than -12. And I divide each side by 12. Cancels x's. Because I'm dividing by a positive number, the inequality doesn't change. So I get a -1. So x is less than -1. And C, I see a double negative, so I'll get rid of double negative before I start. I should simplify my left side before I do anything, so let's rub that out and go 6x minus 1 is greater than 7x. We should simplify each side before I transpose, but you don't have to. You could move the 10 over and 11 over and move the 7 without simplifying, your choice. But if you simplify, then it makes it easier. So the 7 becomes -7x, -1 becomes plus, so -1x, or just x, and I divide by -1, and divided by a negative number, it changes around. Greater than becomes a less than, and I get a -1. So x is less than -1. Again, the double negative became positive, and I simplified the left side first, and then I transpose. We should remove the brackets and make it easier. So 6x, 3 times 2x, 6x, 3 times -3 is -9, greater than or equal to -21. and x is on the left, and the numbers go to the right. So negative 9 becomes plus 9. 6x is greater than negative 12. Divide by 6 on each side. 6 is cancelled to give me 1x greater than negative 2. I divide it by 6 so I don't have to change the direction of the inequality. And did you get the 3 of them right? Hopefully you did. Put your score in. And we're going to solve this one for x. I should remove the brackets first. So negative 2 times 4x, negative 8x. Negative 2 times negative 5 is a plus 10. And if I want, I can add on the opposite, put a little trick, put a 1 right there. And now you can multiply negative 1 by those two. So that's a 3x minus 1 when I multiply negative 1 by the two of them. And we're multiplying 3/4 times 4, so 3/4 times 4 over 1. 4's cancel, and I get a 3x. And 3/4 multiplied by 8. Now I know the answer is going to be negative, so I'll put the negative in. And I'll just work out the 3/4 times 8. So the 8 is over 1. 4 and 8 goes 2, and I get a 6. And we simplify the left and right side first before I transpose. So if I do that, simplifying the left and the right side means you're going to transpose less numbers, less confusion. So negative 8 plus 3 is negative 5. 10 minus 1 is 9. Now I'm going to move the x's to the left and the numbers to the right. 3x becomes negative 3x, plus 9 becomes negative 9. So negative 8x is greater than negative 15. Divide by negative 8. That cancels to give me 1. And I divided by negative numbers, so less than, and that's 15 over 8. Or you could call it 1 7/8. 8 goes into 15 once, so 7 left over. So, but, yep, everything is okay. So just checking it through, negative, yep, 10. Because you're dealing with inequalities, then you could have, any number could work out. Don't have to be, this don't have to be a 2 or a 3 or a negative 1, negative 2. It could be any number at all. We've learned that. Number 10. And again, if you multiplied this line, you give yourself 1 mark. If you simplify, you get a mark. If you transpose, you get a mark. And you get 5 marks. So if you make an error coming down through, then up to that error, you give yourself 1, 2, 3, or 4. And we have solving an inequality with fractions. What I do, I like to multiply by the LCD. An equation or an inequality with fractions, multiply it by LCD. The LCD for 2, 6, and 3 is 6. So I'm going to multiply both sides by 6. So 6 times negative 1/2 x. 6 times 1/6. 6 times 1/3 x. And 6, I could go make that a negative if I want, times 1. So, and every denominator should now cancel. So 2 into 6 goes 3, so that's negative 3x. 6 into 6 goes once, so it's negative 1. 3 into 6 goes 2, so that's 2x. And negative 6 times 1 is negative 6. I could have put a plus right here if I wanted to, and put the negative 1. I could have had plus 6 and put the negative 1 inside, and I still would have got a negative 6. So either or. Because that's negative right there, you can let the negative stay and put the 6 times the 1, or you can put a plus 6, put the negative 1 in, your choice. Now we'll transpose. 2x becomes negative 2x, negative 6 plus 1. Add them up, we get negative 3, negative 2 is negative 5, less than negative, equal to negative 5. Negative 6 and 1 is negative 5. Divide by negative 5, they cancel, and I get x. And I divide it by negative numbers, so that's greater than equal to 1. Give yourself, if you make an error, if you've done these steps, again, you can I always assign part marks. So you didn't get the complete answer. If you didn't get x is greater than or equal to 1, you can get marks out of 3 marks or 2 marks, etc., etc. And total up your marks on the page and put it right here. Let's keep page 404. Now, again, pause the video. You can work out each one of these, or you can work out the whole page, your choice. Here we go. I see 2 fractions. So what I see is an A over B and a C over D. So I know that A, D, and B, C. You cross multiply these. So I'm going to do the same thing right here. I'm going to go 2 times 4x plus 5 is greater than 5 times negative x minus 4. Cross multiply. 2 is multiplied by this one. 5 is multiplied by this one. And when you do that, you remove your brackets. Negative 8x plus 10 greater than negative 5x minus 20. And the x's go to the left, so the negative 5x becomes plus, and plus 10 becomes a minus. That gives me negative 3x is greater than or equal to negative 30. And I divide by negative 3. Negative 3 divided by negative 3 is 1. Because I divide by negative, I change the inequality around, and I get negative 30 divided by negative 3 is positive 10. So x is less than 10. If you have the answer, 4 marks. Now we have an inequality with decimals. We have 1 decimal place, 1 decimal place, 1 decimal place, and decimals on the end. So I have a 1 decimal place, so I'll multiply both sides by 10. You could work it out per normal, move the x's over and move the numbers over and then work with the decimals. But I find, like with fractions, if you multiply both sides of the equation by 10, because you have 1 decimal place, you have no decimals. You have whole numbers. So 10 times decimal 6 is 6. 10 times 1.9 is 19. 10 times 1.3 is 13. 10 times 3 is 30. Notice now when you multiply by 10 on both sides, I could have put, if you wanted to, you could have wrote down 10 times each one, like that. You could have wrote them 10 times each one of these, 10 times these, but because you're multiplying by 10, it's easy to multiply. Sometimes when you do math, you have to try to speed it up a bit to make sure you do okay. So 13x becomes a minus, the minus 19 becomes a plus, so that gives me a negative 7x less than or equal to 49. Divide by negative 7, and 7's cancel out to give me a 1, and divide it by a negative, so it becomes greater than, switches around, and that becomes negative 7. 4 marks. Again, if you have decimals in your equation or inequality, multiply both sides by 10, 100, or 1,000. Eliminates all the decimals. You'll see this in some of the problems, sections, topics you're going to do later on, especially on percentages. Solve and check. Move the x's to the left. Move the numbers to the right. Negative becomes a positive, positive becomes a negative. Negative 3x is less than, and that gives me a 12. Dividing by negative 3, they cancel, I get an x. Dividing by negative changes the inequality, that gives me negative 4. So, not allowed to have 4, but, so if we do a number line, I have a negative 3, greater than negative 4, so that's negative 5, negative 3, negative 2, etc. Negative 4 is there, negative 3, negative 5 is on this side. So you can't have negative 4, so it's a hollow dot, and you're shading. Again, I didn't say what set of numbers, but it's understood. If you're not told what set of numbers to graph it under, then it's understood to be you're graphing over the real numbers. Unless you're told. If you're said integers or whole numbers or or natural numbers, great. But I didn't say, so it's understood to be reals. So I'm going to check, and again, 0 is on the right, so guess what? I'm going to check to see if 0 is good. Why 0? Because 0 is the best number to sub in to check, because it's easy manipulation, easy to work out. So I'm putting 0 in for x. Subbing 0 in. 0 plus 8, that gives me 8. Negative 2 times 0 is 0, and that gives me a 20. 8 is less than 20. Good. So I did shade. Assuming the negative 4 is okay, I did shade to the right. I did change my direction. So that's the solution. Give yourself 4 marks. And the last one, number 14. Solve and graph over the set of real numbers. So now I'm telling you, you got to use a set of real numbers when you solve these. Let's simplify the left side first. So that's a 5x plus 2 greater than 3x plus 4. The x's go to the left. The numbers go to the right. Positive 3 becomes negative. Positive 2 becomes negative. So 2x is greater than 2. Divide by 2 on each side. They cancel and I get 1x. Notice that's a 1. Understood to be 1x greater than 1. Notice it didn't change direction because I'm dividing by a positive number. And we got to graph these over the real numbers. And the real numbers means you have to shade in. If you're graphing integers, naturals, or wholes, you got to use dots. But when you use real numbers, you got to shade. It's not equal to 1. So it's a hollow dot. Hollow dot means that 1 is not included. We have the shade it's pointing to the right. So I have the shade to the right. Greater than is to the right of the number. So there's the shading. A set of real numbers. If you solved it right, give yourself 2 marks. If you graphed it right, give yourself 2 marks. Total up your marks out of 16. When you get that done, then total up each number at the bottom. And when you get it all totaled up, go back to the first page and put your number over 38. Divide with your pencil over the calculator, change it to a decimal, and then multiply by 100 to change your to percent, or move your decimal 2 places to the right. Hopefully everything is great. You did well. Super. And if you like my video, click the like button and the subscribe button if you're not a subscriber. And if you're a subscriber, click the notification bell and write a comment on my video if you're subscribed to my channel. And if you haven't done so, this is the first time, check out my math website, mathfullyexplained.com, and get information about me, my videos, and the content that I'm going to have on my YouTube channel. Thank you very much. Bye-bye.